for this particular question, we are told that we have a hot air balloon which is tied to the ground by two ropes as shown. In this case, I think the first thing that we want to do is we want to draw the free body diagram of this hot air balloon. All right, this should be our first instinct. Now, we have the two ropes which are pulling downwards on the hot air balloon. Okay, so we have double the tension, assuming that the tension in the ropes are going to be equal. Okay, so we have double the tension pulling downwards. Okay, another force that we have acting downwards is the weight of the balloon, all right, as well as the helium that it contains, right? So weight of the balloon plus weight of the helium that it contains. Oh, not helium, but hot air. Okay, weight of the hot air that it contains, right? And the force that is keeping everything up is going to be the upthrust. Okay, the upthrust due to the hot air. Okay, the hot air that is displacing 20-degree air. All right. So, with this in mind, all right, we are going to write down our equation, our force equation. We know that the forces must all balance because the balloon must be stationary. Okay, we have the upthrust, okay, is equal to the weight of the balloon plus weight of the hot air, all right, plus the tensions in the ropes. Okay, so we have the upthrust, which is equal to rho Vg. Okay, but V is going to be the entire volume of the balloon because the entire volume of the balloon is immersed in air. All right, specifically the cold 20 degrees Celsius air. Right, so the density on the upthrust side is going to be the 20 degrees Celsius air because again you are immersing this entire balloon inside the 20 degrees Celsius air. You are displacing the 20 degrees Celsius air. On our right hand side, we have the weight of the basket and the balloon, all right, which is given to us as 700 kilograms. So we're just going to take 700 times 9.81, which is just mg, of course. And we have the weight of the hot air, all right. So the weight of the hot air is going to be rho of the hot air, okay, multiplied by volume of the hot air, all right. And this, bearing in mind, is going to give us the mass of the hot air. Okay, and of course, we're just going to multiply by gravitational field strength or the gravitational acceleration to give us the weight. All right, then of course we take 2t. Okay, we add in the 2t. Okay, so we are given the respective informations already. Okay, the volume of the balloon, all right, is going to be equal to the volume of the hot air. Right, so this is also going to be 2,800. This is 2,800. Okay, and we can key this in. Okay, this is going to be 1.204, and this is going to be 0.898. Okay, so keying all of this in to our calculator, we get a value of 2t, which is equal to 1538.208 newtons. All right, and therefore T is going to be 769.104. So our closest answer to this is actually going to be 0.770 kilonewtons.